Okay, u-Substitution with exponential integrals. Okay, this title is just wrong, and I've been struggling with it. I can't figure out a better title without making it really long. Basically what I mean is that we want to take integrals of exponential functions that take the form e to the u du. Okay? And the integral of e to the u du is e to the u plus c, which makes sense because derivative of e to the u is e to the u. E to the u prime, really. Okay, so let's look at that. So I see I have e to something, so I'm going to say u is x cubed. And so du will be 3x squared dx. Well, I notice there isn't a 3x squared dx, so I'm going to put a 3 and a 1/3. So I'm going to make that 1/3 the integral of e to the x cubed 3x squared dx. And again, I just changed the order, which we can always do when we multiply. Alright, so 3x squared dx is du. This part here is my u. So I get integral of 1/3 e to the u du. And that's integral of 1/3 e to the u plus a constant of integration c. So that's 1/3 e to the x cubed plus c, and you can check that by using derivatives as long as you remember to do the chain rule. Alright, so let's look at the next one. Let u equal the natural log of x, so du is going to be 1 over x dx, and that's true as long as x is greater than 0. Okay, so notice if I rewrote this, I can make it e to the natural log of x times 1 over x dx. So I can tell that's my du, and this part here is my u. So I get e to the u du, which the integral is e to the u plus c. So I get e to the u, I wanted to plug in what my u was, my function x, so e to the natural log of x plus c. And of course we know that x has to be greater than 0, and not even equal to 0. Alright, look at two more. Okay, I see you have an exponential function again, so I'm going to let u equal the tangent of x. So du is secant squared of x dx, and I have that. I have a secant squared of x and a dx, and if you want, I can rewrite the order of that integral. So you can always change the order when you multiply. And as you can see, that whole thing is my du. That there is my u. So I get e to the u du. The integral of e to the u is e to the u plus c. So subbing back, I get e to the tangent of x plus a constant of integration c. Okay, one more. Okay, this one looks a little bit more challenging. Let u equal the arc tangent of 2x. So du is, let's see, derivative of arctangent is 1 over 1 plus 4x squared times derivative of the inside is just 2 dx. Well, I don't have, let's see, if I rewrote this, maybe that'll help. You can see here I need a 2 dx, so I really need a 1/2 out front, and that's okay. So I can rewrite that as 1/2 the integral of e to the arc tangent of 2x times 1 over 1 plus 4x squared times 2 dx. And there's other ways you can rewrite that. So I get 1/2, you know, this here is my u, and this whole thing here is my du. So I get e to the u du, so I get 1/2. Let's fix that with our highlighter, our whiteout. So we get 1/2 e to the u plus c, or 1/2 e to the arc tan of 2x plus constant integration c.